Okay, guys, we're going to jump into the lecture for Recursion 2. Now, this is called Recursion 2, but we're not going to be like adding something on to the fact that recursion is call to function calls. That fact is always going to remain the same. What this lecture is designed to show you is how to loop through nested arrays and nested objects. So, a lot of people were asking me, like, what is the point of recursion, right? Consider this situation. Let's say you go back to that problem, D comma. To solve that problem, you loop through it, check if that thing at that index was an array, then loop through that. And you hard-coded that. You wrote one loop down, went into that inner thing. But this is the very naive assumption that the people running your function are passing in an array with just one level, one deeper level, just one level of array. So you can use recursion to make sure that even if that nested array has a nested array, and if that nested array has a nested array, everything would be added together, whatever, made a deeper copy. But I'll show you how to go through nested and nested and nested arrays of objects in this lecture using recursion, no matter how many levels of nestedness it is. So, let's number object. We'll do this with objects, okay? Let number object will be equal to A will be 1, B will be 2, C will be 4, and D will be 5, right? So, we can write a function. If we just want to sum all the values in this object, we would write a function, sum values, which will take an object, and then we could just do a for in loop, right? For let key in obj, and up top here we would say let total equal to 0. Loop through the whole object and say total plus equals obj at key. Then you return the total. So if you console.log sum values and pass in number object, you would get 12. 5 plus 4 plus 2 plus 1 is 12. Everyone good on this? Looping through an object, taking all the values, summing them together. What if I changed this object? What if I did A is now equal to an object which has a key of B, which is value is an object, which has a key of C, which value is another object, and that has a key of D, and that's 2, and that has a key of E, and that's 5. And then number object outside of this has another key, G, or F, whatever, F, and that will be 5 as well. You see what I'm doing here? This key A, so number object has 2 key pairs in it, 2 key value pairs in it, A and F. F's value is 5. A's value is an object with the key B inside of it. B's value is an object with the key of C inside of it. C's value is an object with the keys D and E inside of it, and D and E's values are 2 and 5 respectively. This is just a nested object with a nested object with a nested object. So, let's say we wanted to find a function. Let's say we wanted to write a function now that gets the sum of all the number values, not the object values. And we can do this with recursion, because if we tried to do this with a for-in loop, you would never know how many for-in loops you would have to write. I can input whatever kind of nested object I want, 7 levels, 10 levels down. If I put in an object with one more level than however many for-in loops you wrote in your function, the function will break. So, let's alter this thing to use recursion to account for this edge case. We're still going to say the total will be 0, right? And we're still going to loop through the outermost object. But in here, let's do some more logic. So first, let's pull out the current value, right? And that is going to be obj at key, right? So the first time we go through this, obj at key will be this object. It will be this object with b inside of it, right? Who's confused by that? Cool. So now that current value, we have that, we can check if the type of current value is equal to object. So when you were doing this with just for loops, you would just do another for-in loop, right? But then that would never account for another nested object. If you just wrote another for-in loop here, the next thing is also an object. So you could not add that to the total. So what do? We just say total plus equals some values of current value. If it's not equal to an object, we would just say total plus equals current value. Then at the end, you return the total. So now you get the same thing. Number object is this nested thing, and we refactored it for recursion. So, before you guys ask me questions, I will run through what's going on in the call stack. Was this helpful last time I did this with the comments? Cool. So, first thing that we're going to do is we're calling some values, right? And some values is going to be called here, and it's going to be thrown onto the call stack. And some values is being passed this thing. So it's going to be an object with A, which is going to be equal to an object with B, and it's going to be an object with C, which will be an object, and D will be 2, and E will be 5, I think. And then here we have F, and that will be equal to 5. This is the same thing as this, except it's in one line. And I'm doing this in one line to show you the stack. So this is the object that's being passed, right? This is just a nested object. No need to be scared, it's just a nested object. With A being the first key, and its value is this. And then its second key is F, and its value is 5. So, if we call some values with this object, we're setting a total to 0. Then you loop through this object, right? Just like a regular for-in loop. Let key in obj. We pull out the current value. So since there's two things inside of this outermost object, this big object and then 5, right? We're setting the current value to whatever it is. So right now, current value is this object right here. Then we say if. If the type of that current value is an object, we know we have to dive deeper down into it to get the numeric values. So if it's an object, total, which is 0 at this point, will be now set equal to whatever total was, plus the return value of some values and current value. So now something else is put onto the call stack. Stop the function right there. Nothing else will be running at this point, because this function is being invoked, and that is going to go onto the call stack. So now we're calling some values again, but this time we're calling it with an object with b as the first key, and that will be an object with c, and that will be an object with d, and d is 2, and e is 5. No f, because f was not the current value. The current value was this object. On the next iteration, it would have been f.
So remember how, like, in the previous lecture, you said you established your base case, right? So are you saying that in this instance, our base case is line 22?
Line 22, no, the base case is line 19. Because we're looking for numbers, right?
Right.
If the current value is no longer an object, we don't want to dive deeper into it. So we found our number, go into the else, and add that to the total.
Well, that's what I said. You don't want to be line 20 here.
Yeah, but the base the base case is technically this. Okay. Like, you're checking to see if it's not an object.
Because I thought that's what, like, you want to stop.
No, right, like this.
So actually, the whole block is your base case.
Yeah, sort of. Yeah. The actual case, though, like the actual thing, like when do I want this to stop? When it's not an object.
Yeah.
So when it's not an object, you want to do this.
Right.
So
you could, like, reverse, like, if you wanted to keep it in those terminologies where you wanted to stop, you could just put an exclamation in the front and just switch it if and else statement. Right?
Yeah. Yeah. So the first iteration of this call is now going to call some values again, except with this object. So we pass that object. Total is now established again and set to 0. We loop through this object, b. The only key in that object is b, with the value of another object. So we pull out that value, which is an object. It fulfills this statement. The current value is an object. So we say the total, which is 0 again, is equal to that total plus the return value of some values of the C object. So now that we're calling it again, this is put on the call stack. That will be an object with D as 2 and E as 5. So now we're calling some values where the outermost key, it's just an object with one key and it's C, and its value is this object with two things in it, D and E. Does everyone understand how we are going through the object? You don't have to understand anything else at this point, but understand how we're diving deeper and deeper into the object, right? Make sense? So, same thing for let key in OBJ. OBJ is now the value of the key C, which is this object. I mean, OBJ is now this entire object, and object at key at C. So current value is this object with two things in it. Is that type an object? Yes. So we have to dive even deeper. We say total, which is 0, is now equal to that total plus the results, the return value of some values of the object with D and E inside of it. So once you invoke that, because you need the return value, you call it with just an object of D and E. Okay? So now this is on a call stack. Everything else is paused. It's not running anymore because now it has to run the thing that's on the top of the stack. So let's see what happens when that happens. We're going to set total equal to 0 again. And then we're going to loop through this object, D to E5, right? D is the key, 2 is the value, E is the key, 5 is the value. So, at the first point in time, let's say let current value is object at key. So, current value is 2, right? We finally hit our base case. This type is no longer an object. So, we will say, we will skip this if, go into the else, total is now equal to total plus the current value. So total is now 2. We're still inside the for in loop because there's another one, E. We do the same thing. Current value is object at key, but object at key is 5. It is not an object anymore. This is a number. 5 is a number, 2 is a number. The total is 2 because we did it on the first iteration of the for in loop. So then we skip this, go into else, total, just like a regular counter with a regular for loop works. The first time it was 2, so now it's 2 plus equals 7. 5. So total is now equal to 7. So some values, the topmost thing, this actually returns 7, correct? So since this is 7, then that means this is now taken off of the call stack, and then some values continues to run. But some values was on this point, right?
Before you take it off the call stack, can you just slack us what the call stack looks like right now so we can take it off on like if you can cut and paste like the whole code.
Yeah, that's okay. I'll leave this here and then I'll edit this one.
Okay.
But this one will be here. So the return value of this is 7, right? But this, you can say, now we look into this function. So this is taken off, and this function was paused, and it was paused because it was running D at 2 and E at 5. It was paused because it was running that function. But now that this is a return value of 7, this is finished, so this is off the call stack. So this is now going to be equal to 7. So the total up here is 0, right? So total plus equals 0.
7.
Exactly. And then you're going to return the total of this. So the returned value of this is still equal to 7. And this goes back even further now. So now this is taken off the call stack, right? So now this is going to be this. But we already, oh, did I fix something? Oh. But we already know what the return value of this is. It's 7. We just determined that when we took it off the call stack. When we got to the base case, it was returned 7. There's no other numbers inside here, so it just keeps pushing 7 back up in that recursion, you know? So now this is 7. So total plus equal, total is 0 in this scenario still. So total is now 7, and this is now returning 7.
Okay? So now this gets taken off the call stack. And now we are back in the original call. The original call, if you remember, had A, which was this giant object, and that's where we stopped. We were calling sum of values with this, right? But we just returned what this is. We just returned what it was. So this is 7. So now total is plus equals to 7. So now total is 7. But there's still another iteration in the for loop. F and 5. F is now the key of the object of the thing that we're passing in, right? So now current value is going to be equal to 7. Object at F is 7. 7 is not an object. So we just add it to the total. And the total was already 7 here. So this, the value of F was 5. So 7 plus 5, the total is 12.
When you just change line 16 to 7.
Like this
Yeah.
is going to be 7, right? It's going to be total plus equal to 7. So now this is 7.
How did that line 16 up? Doesn't line 16 initialize total to 0? So you don't really revisit line 16.
No, so here, so you remember that here, some values,
Right.
we went down deep, found those numbers, we got 5 and 2, added them together, and we returned them back up to
Right.
the original call.
Right.
So now this entire value is 7, right? So then you take total, which is 0,
Right.
and you plus equals 7.
Right.
So now total is 7.
At that point.
And
Right.
then we have to make the next iteration of the for in loop.
Right.
Because
So
there
you're
was
not
another
calling it.
value, F,
Right.
with nothing, with no object. It's just 5.
You're
And
not
that's-
reinitializing it. You're just
Yeah,
resetting
no,
it.
yeah, because it's
Yeah.
initialized up here, but you're looping down
Yeah,
here.
it never goes back up top of the function.
Yeah, so this is now 7, and then it skips this if, goes into the else, and then that total, 7 plus equals 5, so you return 12.
That's what. The whole point is at that point you're not making another function call, another recursive function call. You're already inside the for statement.
So that's doing an iterative loop inside of it with recursion. Because you know you have to loop through something, right? But you don't know if that something is another iterable thing or it's just a number. What you're looking for are numbers. So if you do find an iterable thing, if you do find an object, go into that object and call it again. Call this function into that object. And then look for numbers in that object. And then once you finally find the total, once you finally find a number, return the total. Add it to the total and then return it. And then this function is done running, and then you go back and step out. And if that object, like the one we're initially passing in, had 2 things in it. The first one was an object, but the second one was a number. So once you're done with all that recursion, this for in loop still has to run. It was still on the call stack. It didn't finish running. It finishes running when it loops through all of the keys in that object. And the last thing it had to loop through was F with a value of 5. So that 5 is then put into here because it skips over this. Total plus equals 5. Return total. That's it.
5 is put in which line?
Like at the end of, like when you're getting to here, when you're done with this recursing through this to get the 2 and 5, pushing it back up, this is now 7. And that is defined here. Total plus equals 7. This turns into 7.
Some
And
values of current value.
Yeah, like the current value was this. At the end of all that recursion, and we pull out the 2 and 5, when we pull these out, 2 plus 5 is 7. So then we send that 7 back up as the value of what this would be.
Yeah, but so
And then in the
to
for in
clarify,
loop,
you're saying that some values of current value resolves to 7. That whole statement, the plus equals, like,
For the
everything after the plus equals resolves to 7 at that point.
at that point for the first, because this is a for in loop, right? Right?
Yeah.
So and you pass in number object. The first thing you would do that, the first thing is this, right?
Yeah.
And then the next time it's this.
Yeah.
So the first time that for in loop is running, it's going to do a bunch of recursion because it's like this entire object. And then once it's done doing that, that will equal to 2 plus 5, which is 7. And then we put that on the total. Then this thing runs again.
You put that on the total.
You total plus equals 7. This amounts to 7.
Yeah, so everything that's highlighted there reduces to 7.
Yes.
Yeah.
When object at key is this thing, then you add it to the total. So this is 7, then you add it to the total. Then this runs again, but there's no more objects, it's just 5. So it skips this if, goes to the else, total plus equals current value, which we define here as 5.
I have a couple questions.
What's good?
With JavaScript and recursion, it knows, like, I get how, it's like we go through everything until it starts making sense, like until it finds what it's looking for.
Okay.
But until we get there, like, we're just adding on top of the call stack.
Yeah.
If we don't get to a point in this, like, recursive method where the, like, top thing in the call stack is returning the right type of thing, so in this case a number, is JavaScript going to throw an error? Because, like, with the earlier things on the call stack, we have, like, this thing is going into, like, I don't know who's calling me right now. This is going into, like we get a result that's like plus equals, or total plus equals an object.
Well, yeah,
which should return an error if it actually, if we don't get to that point where all these expressions resolve back
This
into an
with
actual
total
number, right?
plus equals objects will never happen.
Well, it'll never happen, but it's like if we didn't get to the end of that recursion, right? That would be what we get. It's only that, like, at that end point it becomes a number, so then everything else underneath it resolves to a number,
So let's say,
right?
let's
Like
say,
if we didn't get to the end point where it is a number now, then that should be an error. It should be a type error, right? Because we're saying total plus equals an object, and you can't add an object.
no. So look, I changed this to have no numbers inside of this first A, right? There are no more numbers. At the end, all you're going to find is an empty object. So, once we go into that step, and this object is being passed into it, it will say let total equals 0 for let key in OBJ. That for loop won't run.
What if
Because
5
there's
is
no-
also an empty object? I mean, if f is also an empty object.
Then, what are we returning?
Undefined.
We're returning total.
Oh, total.
And total is 0. So if this was 5, if this was this, you just get 0. There is no total. There's no number values. That works if you never find a value. Like if the ending is just an empty object. If it was a string, then the total would be a string. Because JavaScript actually coerces things into strings when you try to add them together. Like if you say like 5 plus string of A, it would be a string of F, a string of 5 of A. So this, like if you, like let's say this is 5. Oh wait, no, this is a typo. Oh wait, no, I messed something up. Ooh, that's weird. Oh. So now, when we find this A, we add that to total. So now total will be this. And then when we get to here, the total, it'll be like, huh. And then the 5 comes at the end, yeah. But then there's just going to be a because every time you're adding 0, the total back, and every time you're returning it, it doesn't just like say like 1 plus 0 is 1, right? And the 0 goes away. The 0 is a valid character, so it does get added to the string. Well, like this is just not something that we're worried about at this point. Like we're still expecting the data to be valid. We're still expecting an object of numbers. What if they were like an empty object? Even if it was an array, because the type of an array is an object, right? So even if it was an empty array, then this would work. Oh, sure. Off. Because this is the only number. What's up?
Instead of like f being just a number,
Yeah.
it was a nested object like about. You walk us through how you do the
So it still works. But after we're done finishing this one, the next iteration of this for in loop would no longer be a number. So it would just do that entire process again, looking for numbers. And once there are no more keys, like they're all empty objects, right? Once there are no more keys, it just doesn't run the for.
Let's put numbers.
Oh, you want to put numbers?
Numbers. And then how it evaluates.
Numbers here and here?
Numbers there also, yes.
Okay.
Different numbers.
We'll do
So
5,
we know how
10,
total is getting calculated.
20, 30. So, once this thing is done, so you guys are aware that when we're going through this function and we see an object, eventually we're just going to recurse all the way down until we find a number, right? We've established that. Do you want me to go over how that works again? You go down, call it again, see that it's an object, go down and call it again, see that it's an object, call it again with this object. Oh, wait a second. Now the for in loop is running on this object, and the values of these keys are numbers. So, we finally get, what is it in this? 15 at the end of all of that. For the first iteration of that. Okay? Of this for in loop. So now that that first big object is done, object still has keys left in it, so this for in loop is still going to run, and we're going to look at that next big object. So we go inside, let current value equal to object at key, which is now this, right? So if type of current value is equal to object, total, which is now 15, right? And that is never going to change. Because sum of values will run with that other nested object, and then it's going to basically do the same thing. It's going to go dive deep, get those numbers, pull them out, and add it to 15 like that.
So first it will become 15
Plus,
plus 20.
plus 50. So it'll be 15 after the first iteration of this, plus 50.
Directly.
You agree that this number object has two keys, A and F. Both of them have the same depth level, and at the end are two numbers. And you agree that you can recursively go down here and get these numbers, right? And then bring them back up and add them to the total. But the original call of this is looping through two things. So after you do all that recursion stuff, the total gets updated here, and then the loop continues. The function is not done running. Total is not being reset anywhere except for here. So, even if we were never to find any values here, when you call this again with another nested object, the total is 0 in that call of the function. Not in the original call, the total is still 15, but in that call it gets reset to 0, and it's still 0 until you find numbers. And then once you find the numbers, you skip this, and then you just say total plus equals that value. So then you update the value, and then you push it all the way back up to the original call, and in that original call, in that world, total is 15. So then total plus equals whatever that value that you got from that deep dive.
So that value is coming as 50.
Yes, because
20 plus 20.
because 20 plus 30, exactly. Because those are the two numbers you find when you're going through this object. So then, at the end of that first call, you just return the total, and the total is an updated thing, and it's 65. Yeah. Yeah. So then, finally, this is taken off, and it's empty. But this is what the call stack would look like, okay? This is a lot, but do you all agree with me that nothing about recursion has changed from what I taught before? It's still calling, a function is still calling itself. That's still going on, this thing, right? Does everyone agree with me? So recursion is still staying the same. It's just now, if you get another iterable object, like an object or an array, and we wanted to like find some value and add it to a total outside, you just have to keep diving in and in and in and in and in, find it, then pull it back out. So now, no matter what I do here, it's still going to dive deep down. No matter what happens, no matter how many nested types of objects are within objects, it will always account for those things.
So the only thing that would throw this off is going in deep. It's not an object. Well, let's say we put in an array inside.
Yeah, then I have to update the function.
Then you have to update the check.
The function I wrote.
Yeah.
Like I have to update something in here.
This is just assuming that we're doing all objects.
Yeah, this is
nested objects.
yeah.
If we have a mix of stuff, you just update like line 28 from then on, saying like that's where you perform all your different checks.
Yeah, because pretty much
Or
you would
actually
have
26.
you would have to write like a for loop.
Yeah.
But you can technically write for in loops with arrays as
The arrays
well.
also is just going to
But-
return a string.
Yeah. So yeah, but this is just for objects. That's what this function does. It goes into nested objects and objects and objects. And in the lecture slides, there will be an example of how to do this with arrays as well. But it's pretty much going to be the same thing. So we're going over this logic like 3 more times. Okay? So,
The mechanics of stack, all that,
Call stack.
that really drives the feature. It's always going to put the first thing last. It's always reversing. Right? So
Call
that's
stack, I don't want you guys to be tripped up about what the call stack is. The call stack is actually a simple entity. You don't actually like in your code like say, hey, call stack, do this. JavaScript just has that built into it, right? And it's saying that when a function is being called, when it's being invoked, it gets put onto the call stack. And it doesn't get off the call stack until it's done running. And this is important because what if the function that you're calling is calling itself? So the first time you're calling that function, it's still on, but then it calls itself with a different argument, like in recursion. So that goes on top of this. This is paused now, because JavaScript can run one function at a time. So now this is running, but the recursive thing hasn't stopped yet, so that one goes on top of that one. And it keeps going and going until you hit your base case and nothing is running anymore. Then the top one can stop running, get pushed off the call stack, return some value. This one can stop running, return some value, return some value. Then finally, the original thing you called can finally stop being paused, finish running, return value, you get your value. Call stack is very literal. Call a function, it goes on. Once it's done running, it comes on.
It sounds like there's a lot of us learning. Like, we come across it a lot where we kind of think about the call stack and like remember that it's going to reverse back to the original.
Not for right now. Later, when you learn about asynchronous code, like what?
Call stack like an intrinsic concept.
Hmm?
Is call stack just a JavaScript intrinsic
No.
concept of
No.
flow?
JavaScript has something like a physical thing called the call stack. Yeah, you'll never see it. It's inside of the language.
Everyone has a call stack.
Well,
For the most part, it's just a
Yeah.
call stack is more of like a terminology that if you have multiple calls, right, like embedded calls, each one of those is a stack. So because each call is going to return something. So if it's all embedded, like how we're doing here with recursion, that's how your stack looks like. It's basically you're performing a call every time, and your stack gets deeper based upon how
That's
many calls
cool.
are doing.
It's like you have a stack of books and you only read the thing that's at the top
It's not-
until you finish it.
not really. It's
No?
like you have. Let's say you start reading like all these books, right? And then you see that this book is referencing another book. So
Yes.
you're like, shit, I have to read this entire
So
book.
leave that page
before I
open.
continue doing it.
So yeah,
Oh god. Oh wait, this references another book. Leave
Yes.
this open.
Leave that page
not to
open.
read this entire
Right.
book.
Yes.
That's what it's like.
Yeah, and that's how your book stack grows.
Yeah, but it's
But
like
you
open
only
book.
finish the thing if you stop getting references to another book that then goes to the
your
top.
final
Yeah.
reference.
So if
Yeah.
you just then the final reference is just like a sheet of paper with one sentence on it.
Yeah.
And you're like, cool, now I can finish this book.
Yeah. And then you go down the class.
And then you find
Yeah.
another book. But that's essentially like what's going on. And the slides will go into this more and more. And I'm going to hammer this in. I'm going to hammer in this like concept into you guys, okay? But honestly, recursion does not change. It's behaving exactly as it's expected to. It's just functions calling itself. Except pretty much it's calling itself inside of an iteration. Yeah. So, what is this? So we have a function logs an array, right? Takes in an array, loops through it, and logs each thing. Cool? So if you say logs an array of 1 and then array of 2 and 3, you would get this. 1 and then an array, correct? Because this is a multi-dimensional array. It's a 2D array. There's another dimension to it. If element is an array, we want to log every number inside of it. If only we had a function that takes an array and logs out all of its values. Oh, wait. So you see here that this function concat_else will create a string, loop through the array, and at each time, at each element inside that array, we will put into this final string, and then we'll just return the final string. So this concat array takes in this array of strings, and the result will just be a string ABC. This isn't anything new, right? This is just looping through an array and making everything into a final string, right? Cool. But now, what is this?
It's kind of out of order.
Yeah, something's out of order. I don't know what's going on. But now, we have the same thing, but now it's going to account for nested arrays. So let's say you're passing this function, the function I just showed you before, it takes an array of strings, right? But let's say that thing that's being passed into the function also has an array of strings in it. So it's a multi-dimensional array, right? So how do we account for this? We write this function. Concat_L takes in an array, same thing, let final string equal this. This is the thing we will be returning. Then you do a for loop. You loop through the array in the same way. But you pull out the element and you check array.isArray of element. If it is, you're going to say final string plus equals concat_else at element. Does this look very similar to what we just did with objects?
Yes.
This looks almost exactly the same, right? Except it's a different if condition, checking for arrays, and a for loop, and not a for loop. So at the end of everything, once you find the actual string, final string will just be added, the element will just be added to final string. Then at the end of everything, you return final string. So let's look and see what the call stack looks like. Oh, this shit is all out of order. Oh no. Let me just skip forward for a second. We won't go into this right now. Okay. No, I got up to the next thing. So we're going to look at what the call stack looks like here, okay? And we'll go back to that logs or anything later. So here, the call stack is going to be called down here with A and then an array with B and C in it. Does everyone get that? That when we're calling it here, you can't see it because this box is cutting it off. But the first time you call this function, this will go onto the call stack. Right? That function's being called, boom, goes onto the call stack. And at that point in time, the final string is just empty. We haven't done anything yet. But then we look at A. That's the first element. Right? We go through it. The first element is A, so we go through it. Is that an array? No. That is not an array. So we say final string plus equals that element. So now final string is going to plus equals A. So with the first iteration of this array, final string is now A. Everyone agree? We found that. But now, when we get to the next thing, A is going to, the next thing is this array of B and C. So in this for loop, this if condition is satisfied. Array.isArray of element is true. An array of B and C is an array. So we enter this if block and we say final string plus equals the return value of concat_else of that element, which is this function. So we're going to say we're still in the same function, the same first function. It's running. But now it's going to plus equals another function call with a different value. And that value will be an array. So that gets thrown onto the call stack. Does everyone get that? Does everyone get that? Really? We hit that recursive call, and that function is now being called, so it goes onto the call stack with a different value. Now, this function is running again, and this one is paused, where the result string already has the A in it. So now we have just an array with two things in it, B and C, two strings, right? So we go through this for loop, and we say we pull out the element, first one's B. Is that an array? No. Add it to the final string. So the final string will be B at that point in time. Now we go to the second thing in the array, and the second thing in the array is C. Is C an array? No. Skip this, go to the else, add it onto the final string. And the final string already has B in it, so B plus equals C is BC. Then the for loop breaks. We are done going through that array. So we return final string. Final string is BC. And if you remember in the first call, we're setting A on the first function on the call stack. A is plus equals to the return value of concat L's at B and C, an array with B and C. So we've just established that the return value of that is a string B and C. So here, A is plus equals to B and C. So the final string is ABC. Cool. What's up?
Like, where is A getting stored when we're doing like B and C?
When this function is paused because something else is on the call stack, final string has A in it. That's
it's
never
like
getting.
outside of this.
It's not outside of anything.
It's
That
not
function
outside
call?
of this recursive loop.
No,
No.
the recursive loop is happening inside of the outer call. Yes, not really, but like you could think of it that way.
So
if you
does
want
it
to.
create different instance of that variable every time the function
Yes,
gets called?
every recursive call,
Okay.
let
that's
final
where it's
string
getting
is
used
defined.
separate.
I didn't hear what you said.
Every time you're running this recursively, let final string is being defined again. But the first time you run it, and you found A, and you don't call it recursively, final string is A. Do you agree?
Yeah.
Do you?
You said
Like the
Can
first-
you say it again?
Like the first time you pass this array into it, the first element is just a string, right? It's not an array.
Yeah.
So it skips this if and just adds it to the final string, right?
Yeah.
Like if array dot is array of element, the element at this point is A. Is that an array?
No.
So it goes into here and it just adds it to the final string, right?
Yeah.
So final string is A. Now,
You're pointing
continuing
to the final string outside of the brackets,
Outside of the
curly
for loop.
brackets of this loop.
outside of the for loop.
Yeah.
Yes. And this, because this function is running normally so far, right?
Yeah.
But now the next element is BC. This is A, right? Still? Like,
Yeah.
because we're still inside this for loop, and it's BC.
Yeah.
They're still running this function, but now BC is an array. This is satisfied. So final string is going to be plus equal to a function call. A function invoked with that element. This function stops running. It's still in memory. Everything is still saved, but it stops running. So the first time, final string is A, and that's still there. And this function is waiting to finish running because this is going to be thrown onto the call stack and run with completely different values.
So most of the time, A is still there. It's hanging out.
It is hanging out.
Waiting for the actual array in that array.
Yeah.
To, like, run.
But so is it right to conceptualize A as being like stored in this like outer variable final string, and then when the loop finishes, it adds BC to that, and then it like is complete?
I guess you could think of it that way. You can think of every time you're calling this recursion, that final string is different. It is. You're defining it different. You're defining different things. Over
It's
and
like
over again.
first it's A and then it's ABC.
First
when
it's
it's
A, then it calls, and then it's reset to this. But A is
It's
still
reset
stored
to blank.
when you
Yes.
call it again recursively. Because
second
like
one
when
is
you
separate
call
instance.
the function, this is set to blank, right? Like the first time, it's set to blank, right?
It's the same
When you-
instance.
I don't
The
know what
same
you mean by
variable.
instance.
Okay.
If you call the function at all, the first line in the function, you're saying final string is blank, right? When you just call it the first time, right?
Yeah. I mean, I wanted to say
Each one of those
something
items
more.
on the lines on the call stack, that's your instance. When she refers to instance.
Okay, so an instance is just a line on the call stack.
Yes.
Okay.
Yeah, you can say it, like an
That's-
instance
that's
of
the
a
way to
function
think
call,
about it.
whatever. if
Yeah.
You want to say
Yep.
it.
Okay.
Every time you're calling
So-
something, every time you call concat else,
It changes.
the function is running, so this is the first line in the function. So we're defining a new final string of an empty string
Mhm.
for the second time we're running.
You
But
said
the
we're
first-
defining a new.
Yeah,
What
the
was
second time it's run.
Can you say that just that last sentence again?
You
We're
run this function, right?
Yeah.
And it finds an array. Let final string was defined as this, and then the first time A was put into it. So the final string is A. The function is still running, it still has another thing to go through.
Yeah.
It finds an array, it calls the same thing again. It's a different function call, so all the variables will be reset in that function call.
Uh-huh.
The first
Yeah.
function call, everything is still the same.
So-
But that function
Okay.
call, this is reset, and then it loops through and adds all that shit to it. And then
Okay.
Yeah.
you return what that final string is if you don't find any more arrays.
So maybe the more accurate way that I should conceptualize this is that like we have these two separate instances, and in the first one it's like the final string is equal to A, and in the second one it's equal to BC, and then when everything is finished,
It's ABC.
it gets like elided into ABC.
Yeah, because BC.
But it's not like it's some internal external thing. It's more it's like sequential. That like
It is
first it's
sequential.
A,
Yeah,
then it's BC, then you add those together.
pretty much. Yes.
Right.
But there are
Every
three
time you
different
call-
files.
Yeah, the instance.
Every
I just
time
didn't
you
That's
know
what
that.
I
call,
heard.
that's,
Yeah.
that's your instance. Every
Okay.
time you make that call
Yeah.
on line 6, you write it down in your call stack. That's your instance. And then you keep track of what that final string is going to be until you reach the last condition. And then
Yeah.
you bring everything up, like you said.
So is that more accurate to say than saying that like first final string is equal to A and
Yes.
then it's equal to ABC? That it's really like we have these separate instances that just when
Yeah,
it's all complete, it's
Yes.
ABC.
Yes.
Yes.
When it's all complete, it's ABC.
Right.
Okay.
But they are different variables. They're
What are
being
different
defined,
variables?
like when you're calling the function again, it's a different instance of the function, right?
It's a
It's a
different
different
stack.
entity. So you're defining final string again inside here and setting it to 0. So we're setting it to empty string.
Right.
But in that part, it's A. But this has to wait for this one to finish running. But this one's being called from the beginning.
Because each time it loops, we say let final string equal blank string. So that's what
Yes.
you mean is
So
when
then
it's-
this one
it's resetting.
is just an array of strings. Final string is blank in this one, and then you just do it like normal, BC, right? And at the end, you return final string. So this becomes BC. Final string with A is now A plus BC.
Yeah.
ABC. Does that make a little bit more sense?
Yeah, no, I think that makes more sense.
I don't know if you're went over this or if this is even an issue. So why didn't this return as CBA? Why did the backward stream print out as YDBAH?
In that, in the
what
other
did
function?
in that one that made it, when we did the recursion that made it print backwards versus this is going in order, ABC.
Well, I think
Well-
line 13 is concatenating them, right?
What is line 13?
Right there at that let condition.
So we already have a.
Oh, no, this is just calling the function. This is a function definition. This is calling the actual function. The reason why this is going in order is because the for loop, I is set to 0. So we're always going to look at that first one, and then final string will be A. This will be added on to the back of it.
But isn't
If
that
we
what
wanted to reverse it, we would reverse the for loop. We would set I equal to array.length minus 1 and subtract I until it's 0. And then you would go backwards, and it'd be the same thing.
I thought that's what you did too.
In that other,
I guess it
in the other workshop,
yeah, backwards string.
well, backwards string, you're passing the last element in the array and then taking it off, and then just passing the entire string.
I was just interested.
Okay, yeah. Okay, let's continue. So let's go back to. Oh no, dude. Oh no. What is the point of this?
Were you asking, Grace, were you asking why it doesn't shoot out BCA?
Because in our class we have for the two results from 0 up, but then it returns back.
Were you saying BCA though?
So here's a more clear example than that complicated finding elements and returning them. This isn't returning anything. This is just going to iterate through everything using recursion and console logging the element. So the function logs an array will loop through the array. It will pull out the current element. It will check if that element is an array. If it's not, it's going to console log the element. If it is, we're going to call logs array on that element. And at the end, we're not doing anything. We're just going to check the console. So the first time you call this function is down here, right? This is where it's being defined. This is where it's being called, right? Logs array is being called here. So you call logs array, and it goes onto the call stack with 1 and then an array 2, 3. That gets thrown into here, and it's looping through that array. This array has 2 indexes, right? Index 0 and 1. 1 is an array. 0 is just the number 1. So we're looping through it. The current element is 1. Is that an array? No. It's just going to console log it. And then it's going to run through the loop again. But now, the next element is going to be 2, 3, an array with 2, 3 in it, right? So this if condition will be satisfied, and then we're going to call logs an array again. So a new call of logs an array will be put on the call stack. So the current thing that was just running is put on pause, and then a new function call will be made, but the argument will be an array of 2 and 3. That's put on pause. This has to finish before that one finishes. So this function is now running, and it's the exact same function. So you go through that array. Current element is 2. It's not an array. Log that. Current element is 3. It's not an array. Log that. Now it's done running. So then, when it's done running, you get those console logs in the console. Then it gets taken off the call stack. But now, since there's no more elements in this array, the for loop finally finishes, and this one can finally finish. So this one gets taken off the call stack as well. Does everyone understand this? Sort of. Okay. It's just like a less complicated version than from this. So, now we'll talk about nested objects. So we're going to go back into the example that I showed you guys before. But I think many of you might agree with me that the logic we did in that array thing was the same logic as I did when I coded it out for you, right? So, working with nested objects is very similar to working with nested arrays. use a for in loop to iterate through the object, and if the value is another object, just recursively call the function on the nested object. Oh, wow. This is the same thing I did. Wow. So you set let, well, this is how you would do it if there wasn't any recursion involved, right? So you say sum is equal to 0, you loop through the object, everything you add to 0, then you return the sum. Such a simple function, we're all good. But, and you get 30, because you're putting in an object with A is 10 and B is 20. But, let's say you pass in, that giant thing I passed in. Sum is 0, and then you loop through that object. And that object has all these different nests. Well, I think it's just, this is hard to read, but I think it's just one key in it. No, there's two keys. A is the first key with 1, and B is the second key, which is this object. So A gets thrown in first. Its value, well, I mean, the object is being looped through, so value is, the key is A, so object that key will be 1, right? That is not an object, so we don't do this, but we do this. So the sum is now 1. Then on the next iteration of the for in loop is when we're going to be passing in this nested object. And right, so the first thing on the call stack is the whole thing with the thing you're calling, right? So the sum, like I just said, will be 0 plus 1 because the first thing is A and that value is 1. So the sum at that point in time for that function call is 1. But now the next thing that happens is that you pass in this big object, B. The value of B is this big object. So that goes through here. Sum is set 0. Well, I mean, sum is 1 still. And we're still inside this for in loop. But now the next value is that object. So then we go into here and we say, hey, this is an object. Sum 1 is plus equal to the result of some vowels of that object. Now that function pauses. Another instance of the function starts running with a different value. And that is thrown on the call stack. And the sum is 0 when that's run again. Okay? Do you see how here 1 is plus equals to some vowels of this? Some vowels of this object with C, D, E, and F in it. So that is thrown on the call stack. This pauses. This runs now. Sum is 0. Loops through this object. Says, hey, what's the current value? Oh, the current value is another object. So we're going to say sum, which is 0, is plus equals to some vowels of that current object. And then we're going to pass D, E, and F, that object, back, and we're going to call the function again. So now there's a third instance. Well, second instance. There was one instance, now there's a second. I don't know, whatever. There's 3 things going on. 2 things are paused, 1 is starting to run. Sum is back to 0. And then we're going to start the for in loop. We're going to look at the current object and check if it's an object. It is. So we're going to do that. So sum is 0 is going to be plus equals to whatever some values of E2 and F3 returns. Whatever this call returns. So this function is now put on pause as well. And then that thing enters the call stack. Some values called with E2 and F3, right? An object with 2 keys. E value is 2, F value is 3. So that's 2 keys. Sum is set to 0. Enter the for in loop. We're looping through this small object now. Value at obj at 2. obj at E is 2. So value is 2. Is that an object? No. Skip the if, go to the else. Sum is now plus equal to 2. Sum is plus equal to 2 now. So the sum is 2. Continue that for in loop with the next thing, which is f and 3. Sum is now 2, but now it's going to be plus equals to 3 in this situation. The value is 3. So now the sum is 5. And now there's no more keys inside this object, so the for in loop is done. The for in loop is done running in this function call. Only one more thing left to do, return 5, and then take that function call off the call stack. So the return value of this will be added to the total in this call. So it returns 5, so then 0 plus equals 5 over here. And this thing can continue to run. So once this equals something now, adds it to the sum, which was 0, add 5 to 0, there's no more keys in the object. This big object has one key. For in loop breaks, returns the sum. The sum is 5 still. So now we know the return value of some vals, d each, this thing, is going to be like right here, right? So this is going to be equal to 5. So that function can get off the call stack, and this function can continue to run. When that function continues running, this will be equal to 5 now, and we'll add it to the sum. Then the for in loop breaks because there's only one key in this outer object. So once it's done doing everything it needs to, it breaks out of the for in loop and returns 5. So now we remember that in the original call we already had the sum as being 1. So 1 plus equals 5 because that's what was returned from this call. No more keys. We already went through A. We just finished going through B. It's being returned here. No more keys. That's it. Return what 1 plus 5 was. It's 6. And that's the total. So.
Can you go to a slide where the boxes look something so I can see all the code?
I think the only thing that this is covering is when the function's being called.
Okay. Well, my question is,
I'm pretty sure.
You said we have to think of a base case and we have to think of a step to satisfy the base case. Can you explain the process for this? Or can you point out the base case and express your mental process to think of that base case, and then point out the step towards that base case and point out how would we write that? Your like mental processes of what do I
So
do?
my mental process to go through like what would this problem even be? What would they be asking you to do? They'd be saying, no matter how many steps there are, no matter how many nested objects there are in the input value, find the sum of all the values and dive deep down, right? So I'm thinking right away like, oh, if you don't know how many values this is, I have to use recursion. So the first thing I would do is saying, well, I still have to loop through the array, the object, whatever, it's the same thing. You have to loop through the object and the array. And basically, when you're done checking that each thing is not an object, when you're done checking, you have to check and see if it's an object or not. Because let's say, like right away, let's say the input value was just an object where A is 1 and B was 2. Then there is no recursive call. So right away you know that, okay, well, I only have to do recursion on special conditions. So first I can write a function that deals with the most simple call, the most simple input, which is just an object where A is 1, B is 2. Then, after you're done writing that logic, you can say, okay, well, what if there's another level? then that's when you think, okay, so then I'll write this if statement. So if it's an object, what should I do, right? Because if it's an object, you don't want to add it to the sum. You need to do something else. So you don't even have to write this yet. You just have to think like, okay, let me stop right here. Let me think about it. If this is an object, what should I do? What should I do? I could write another for in loop, but you don't know how many levels down it is. So if that's an object, what am I going to code out, hard code another for? No, because then it's just impossible to know. Because the input could always be one more than what you wrote. So if you know you're eventually going to reach a number, even if it's not a number, even if it's empty, you know that you could just add the outer sum to whatever this returns, because you're always going to be returning the value if it's not a complex structure. This is a hard problem to do if you've never done this before.
The if and the else, this is considered the base case there.
Yes. If it's complex, you keep going. If it's not complex, you return. Well, you just add the sum and don't call the value. Don't call the function again. Because since there's other things, you still have to keep looping. So after the loop is done, and there's no more complex values, that's when you finally return that function call.
So this is just the general format of anytime you're keeping a tally of something, you always want to start off with an initialization of what you're trying to return and set that to 0. That's the general.
Even if there was no nested stuff, that is general. You set a value to 0 if you're adding them all up.
Because
if you're multiplying them all together, this would be 1, because something times 1 is itself.
Because the mistake that I always had was, I don't know what I was doing wrong, but I did it in this format, but it would always keep resetting, and I would not get the proper results because everything would always come back to 0 for some reason.
Because the thing is that you have to do is you have to set that sum equal to the return value of this, otherwise set it equal to the value, and then return it.
Right.
So.
Yeah, I just did sum equals sum, and I didn't do sum equals sum plus that.
Yeah.
Because it wasn't adding to it. Okay, that's.
Yeah, if you just reset it, then nothing's.
Yeah, that was a mistake.
You guys ready to take the practice assessment?
Right now. Everybody.
No, this is rough stuff, honestly. This is rough. But I think the most important thing to know is that recursion is the same. This is just using it in a different way. The logic is sound. It's there. Go over it. Understand what's going on. Go over the call stack. If you're still stumped on this, take out a piece of paper, write down what function is being on the call stack with what values, and write down when it's paused and when it continues. Do that so you really understand how it's working. Okay? We will see. That is true. Oh, shit. I have to go through all of this again. So you get 6. So the recap. Oh, shit.
Wait, so just for what you were just saying about troubleshooting this, if you're stumped, you would just have the column or the 2 columns like you had on the side, right? With the function being called on the left and returning what on the right?
Yeah, so if you're looking for an accumulating value, like the total, right?
Yeah.
You would say, okay, I'm going to throw this onto the call stack, put that down, and then next to it, what is the total at that point of time when you're calling that function? At that point of time. If you're altering the total before you're making the recursive call, the total won't be 0, right? It'll be whatever you changed it to. Like in that array question before, the first value was A. So it updated the final string.
Yes.
But you didn't make a recursive call yet. So then you call it again on the second value, which is an array, but that final string is still A. So when you're calling that, you update the final string, pause, call it again. Final string is blank. Run through the function, final string is B. Keep running through the function, final string is C. Function's done running, return the final string. BC is returned A, final string, return duck.
Yeah.
You know?
I get that. I'm just trying to like think just more step by step because I'm not like the point of doing this is that like if you're stumped, you're probably not able to combine all the steps together in like one.
Well, yeah. Write
thought.
down what the value is.
So the
at
thing
each
that I
point
just
you're
wanted
calling.
to ask was like you're gonna have one column with your function and what the other column with what's being returned by that function at that point in time. You said another thing about like if it's getting paused. I was really just wondering about like if it's paused, like how are you gonna annotate that or like. Or
If
I
it's-
don't. I'm
you
just
know-
trying to imagine like
you
because I'm
know-
gonna need to do this.
you
Like
know
how I'm
it's
actually
paused.
gonna write it.
You know a function is being paused in that like diagram if you're drawing it. You know that function is paused if something's on top of it.
And that's all. Okay.
That's all.
Okay.
If there's 5 things, the top one is running, everything is
else
paused.
is paused.
Everything is paused. And
Okay.
then once that one's done, it's not like the one on the bottom is going to start running out of nowhere. The one on the top has to run first. That finishes.
And it seems like you can
Everything's still
annotate this by just like whenever you get to the top, you can basically just have like an arrow from the thing at the top down to the thing immediately below it, being like this thing is gonna resolve to
so
this
if you
value
have that,
to this
if
thing
you
to
have
this
that
thing.
diagram, yeah, you can
Yeah.
do like that to that to that. It's
Yeah.
sort of.
It's kind of like feels like a kind of grammar, like a syntax thing where you're like drawing arrows to like this thing
Yeah,
is
I guess
modifying this, is modifying this.
Yeah, but that's how you would put the diagram.
Okay, cool.
I think that would help.
Yeah.
All right, guys, take 5 minutes, and I'll open the workshop.
I have the backwards rule.
Yeah, you want to come up here? Take 5 minutes.